Okay, in this tutorial, what we're going to do is we are in Amazon Bedrock Agentcore samples, and we are running Python. We have a virtual environment set up. We are in advanced concepts in Agentcore Observability, and we're looking at data protection. So let's go to the README file first and read what this is all about. So if you go to the README file, it'll tell you what this tutorial is about. So in this tutorial, we're going to learn about implementing comprehensive data protection and agentic AI applications using Amazon Bedrock guardrails and data protection policies in CloudWatch. This tutorial demonstrates how to protect sensitive data throughout the agent's lifecycle, from input processing to output generation and logging. Okay, and some of this stuff is straightforward. We will focus on creating a defense in-depth strategy for securing your AI applications by combining multiple layers of protection that work in tandem to safeguard personally identifiable information. They call that PII. PII is your name, your phone number, your email, etc. Bottom line is that's that. And they also mention financial data, health records, and other confidential information. Okay. They talk about the tutorial. It's observability and security. It's the agent type is single. We're using strands agents, Haiku, LLM. Tutorial components are data protection, Bedrock guardrails, and CloudWatch logs data protection. Okay, it's cross-vertical, it's an advanced tutorial, and it uses Bodo 3, which is Amazon Bedrock Agentcore Python SDK. Now, it says here we demonstrate how to implement data protection mechanisms for agents deployed on Agentcore runtime. We'll use a customer support agent that processes sensitive information and show how to protect this data using multiple layers of security. Now remember, okay, you're a client, you're calling Agentcore Gateway, you're calling Agentcore, you're running in an Agentcore runtime, you're logging, we're using observability, we're logging in files, we're using X-ray, we're logging spans and traces, etc. And so what this demo is trying to do is say, hey, how do you do that securely? How does Amazon provide the security? And the features are this: implementing Bedrock guardrails. Guardrails prevent you from exposing information you shouldn't be exposing, right? So you could prevent the customer from querying certain things that they shouldn't be, that they're not entitled to. And CloudWatch logs your logging information, and we could have data protection in the CloudWatch logs. That is my email, my phone number, my Medicare number, you name it. Sensitive information detection, automatically detecting PII, financial data, and other confidential information. Agent security, protecting sensitive data in agent interactions and traces. Compliance support, meeting privacy regulations, HIPAA, CCPA, CDPR, these requirements. Okay, so in other words, we want to sell you this product and this solution, and it has all these features, and this is how we're going to do it. Defense in-depth strategy. We're really just creating a comprehensive security for agentic AI applications. Okay. Now, some of this stuff is already used in Amazon, right? You could, although we write custom solutions to a lot of crazy things, some of this stuff exists. And this is in the context of agent interaction. So it's making sure that that scope is secure. Okay. How do you detect sensitive information in agent interactions and CloudWatch logs and traces? We'll see that. Amazon Bedrock guardrails, how to configure sensitive information filters to prevent AI agents from processing or generating sensitive content. CloudWatch logs data protection, how to automatically detect and mask sensitive data. Agentcore integration, how to implement those predictive measures within agent workflows. Okay, and it, it says here why this matters. You can't expose sensitive data. It violates privacy policies. You generate PII information that shouldn't be shared, and you want to create compliance and security. You want to avoid compliance and security vulnerabilities. Okay, so the files we have here is the notebook, the input requirements file. We have some data. There's some customer conversation in here, and there's images, architectural diagrams. Now, so we just looked at the README file, and to be honest, most of these Jupyter notebooks have the documentation in the Markdown where you can define comments here. For some reason, it's not showing right now. But so let's look at the folder, data protection. So there's data here. There's just a conversation sample. And Nick Wolf seems to be telling us his email, his address, and everything else like that. That is all PII information, and we cannot log that, we cannot show that, we cannot share that. So this demo is going to exhibit that. There is a CloudWatch data protective policy, and now I know this is not new, but it's relatively new because we don't really use it much in CloudWatch. When we could, because we write custom loggers and things like that, and there's PII data that's filtered. But this is a policy that protects and masks sensitive data in the log files. So, data identifier, there's an audit policy, and there's a redact policy, and we could see what that looks like. Loosely speaking, it's gonna mask the email addresses, phone numbers, names, social security numbers, bank accounts, credit card numbers. Now, if you look at AI tools like Comprehend, you could do that automatically. You could throw it a conversation, and it would mask all that information. So, this is important because it's logging in a certain place in a certain log file, maybe like a span file or a trace file. It's important, but there's other ways to do these things. Okay, so that's the policy. Let's bring that down. Okay, there's a requirements file. I already installed these things: strands, package manager, SDK, Agentcore, Starter Toolkit, Open Telemetry for Strands, and Amazon. Okay, and that's about it. So now there are architectural images in this folder here that you could look at. Agent response with Bedrock guardrails, data protection, response with data protection enabled, without data protection, observability data protection architecture, after data protection is enabled, log with data protection, guardrails, etc. So we could look at these a little bit later, just to give you an idea of what we're doing. But okay, so I'm thinking now, look at the architecture images or go to the console. I'm going to do both of them, but let's look at the images first. Let's look at the images first. Okay, this is agent response with Bedrock guardrails. Okay, summarize an agent conversation. Tell me exactly the phone number, name, and address, and email. Well, if you look at this box here, the agent conversation summary, it doesn't show you the agent name. It doesn't show you the phone number. Etc. So okay, so that's just one image. Let's take a look at the other one. Data protection enabled. Does this look the same? It's got the data protection. Let's see what the difference is between this one. Okay, so email, what the conversation is about, and let's look at data protection. To me, it looks the same. So I don't. Guardrails is more like you're not going to get back something from the response. You can't even ask the question. So tell me exactly phone number, name, and address, and email. Gee, I think there should be guardrails for all those things. But anyway, I'm not going to waste any time on it. We'll see it in the console. Okay, let's look at this one. Response without data protection. So notice the email is showing the email. This is an agent response without data protection. Okay, so far I understand the data protection ones. All they're doing is they're basically just either showing an email without data protection, or it's masking it. So that's the data protection part. So let's move on. Let's look at the data protection architecture. So this I understand. This is very high level, but the user talks to an agent. An agent invokes an LLM and processes output. But there's guardrails here. So the processed output would be limited. Like suppose a user wants to generate 20 images, and there's a guardrail here that says you can only generate one image because the service is free. That would prevent the user from making the query. So And then there's also Agentcore Observability, and here's where the logs happen. We're logging information for spans and traces, right? And the bottom line is we don't want to show any sensitive information because these things are scraped and shown in the observability tools. So we don't want to show you anyone's email, anyone's phone number, etc. So there's also a mechanism here to protect that. So we're taking multiple precautions here is what this architecture is saying. Okay, logs after data protection, log group policy says manage data identifiers, account number, credit card number, etc. You could actually see it in the log configuration, the log group policy. And notice we're in the agent. We're in the agent, in the runtime in the agent, and we're looking at the log policy for the agent, and we have this information. So, so that's good. That's good. Okay, data protection enabled logs. Okay, so this is an example of a log file with data protection enabled. You see filtering of certain information. You don't see, or you could fill it with a type, like the PII type is a name and a phone or an email, etc. So I like this because you could filter, do log insights based on these things and see where these things are showing up. If it's like this, you can't. You really one level more deep, one more level secure, but however, you can't really search and find things. This has logs with guardrails and no log data protection. This is interesting because okay, so this is interesting because here you're logging and you're not you know there's no data protection. So you see the email and the phone numbers and everything else like that. Now you also see this customer name and phone number and email with the PII type. So if they're trying to say that this is guardrails doing this, well, that's good news because I didn't know guardrails can do that. Because I don't know if that feature has been around all the time. We'll take a look at it in the code. But guardrails are usually, protecting people from making multiple queries or getting protected information. That's good. Logs without data protection. Once again, you see the email, the phone number, and everything. Not good. Bedrock guardrails. So this is a trace with a Bedrock guardrails, and so a trace is like a request response, right? It's like the customer talks to the agent responds. So the guardrails come in to the Bedrock picture, and basically this says a guardrail intervened. And obviously it shows the PII type here. Now I don't know, we'll have to look to see whether it addresses PII information. Of course it is, but I'm trying to figure out if the guardrail deliberately did not catch this. We'll take a look at that. Okay, next image. Data protection, a trace with data protection enabled. So this is a trace, and we're looking at a trace ID, and we're looking at a request response from a customer to an agent, and we're looking at masked information about the user and the agent email, agent ID, etc. Good to know. Guardrails with no data protection. So let's see what we have here. Agent Bedrock, we see the email, we see the agent ID. Trace had guardrails, but I don't know where they came in here. Interesting. Okay, a trace without data protection. Of course, you see phone numbers, emails, addresses, everything else under the sun, and you know, this is an output message. So this is going to the user, and that's a no-no. Okay, that was fast enough. Let's try to run the notebook. So I already installed everything with this here. Now I'm going to write data protection Python file. Okay, quickly going through this. This is supposed to write the file over here, which I'm not seeing at the moment, but there's something refreshing my PyCharm. It's available. So this has a tool, agent call summary, summarizes the contact center agent interaction, the results. We're opening this file, we're getting the results, logging the information, returning the results. We must be we're just simulating the results here. Get Bedrock model, we're using model ID is anthropic, and the temperature is 0.7. We got the maximum tokens, successfully initialized the model, get Bedrock model, and now we instantiate an agent with the Bedrock model, a system prompt, the tools, the agent call summary, and the trace attributes, strands, observability. These are tags, customer support, observability, strands. Now let's take a look at this again. Agent call summary is a tool, and we're just calling that tool to get some conversation, right? The system prompt basically tells the agent the role it plays, right? You are an expert customer support conversational agent specializing in finding accurate and relevant information. Your role is to efficiently search, analyze, synthesize information provided to answer the user's queries comprehensively. You should provide well-researched responses with the current information, clear summaries, add cite reliable sources, and cite reliable sources when presenting your findings. If the user asks to perform a task that can be accomplished with a tool, you must use that tool. Now, look, the system prompt, the more precise it is, the better off you are, because you're going to get what you need. But you could also be slowing this thing down, right? But the fact that you're mandating that it uses a tool to find the information means the LLM model doesn't have to run billions of parameters. It could just call a tool and get an answer. So there's some goodness in this in this system prompt. Now notice the tools have the agent call summary, and now you have an app entry point. This This is the thing that gets deployed in Agentcore. This is the endpoint that you call by the agent to pass in the payload and call Agentcore, right? So let's just take a look at it. Customer support agent. It has that app entry point. It's printing information. Get the user prompt. It prints information. If not user input, summarize agent conversations. For Jane Doe, tell me exactly the phone number, address, blah, blah, blah. Support agent, user input. Here's our support agent. Okay, now it wrote to this file. I don't see it over here, but it should be here. And you could see it, but the file is right here. Usually when I do a find or I search something, it winds up showing up. Sometimes it doesn't. So we have the file, the data protection file. Now, in this code block, what we do is we import the runtime from the starter toolkit, the session from Bodo3. We instantiate a session. We get the region name. We instantiate the runtime. We define the agent name, and we configure the runtime. And the runtime is configured with the entry point, which is this file. Create a role. Create an ECR registry. This is the requirements file. This is the region. This is the agent name. No memory. Let's see what this thing does. I'm getting this warning, which I'm just going to ignore. It says entry point parsed. This is the entry point. You know, this is the file of the entry point. Memory disabled. Generated a Docker ignore. Setting customer support agent. Bedrock configured using this YAML file. It should all be appearing here, which it's not. Okay, so I'm going to go over here for a second, and let me see if I could get this to show up. It's getting dark here, so I can't really read. So at the moment, I have no idea where my files are, but we're going to launch this. So what happened here is We prepared everything. We created a Docker image. We could launch this thing, and the Docker image would go over to Agentcore, would go over to Amazon, get registered in the ECR registry, would run a code pipeline, it would get deployed. The Docker file would run, and basically it would expose an endpoint that we can call. That would be our agent, right? So this was configuring the runtime, and it had all this information that it needed. The Docker image is going to run, and it's going to make sure that our agent's deployed. Let's see here. But that's launching. Okay, so when we launch, let's see what happens when we launch. See, it's really annoying before I ran this to not be able to see my files. The Docker configuration and the Docker file should be visible to me. Okay, so let's see what happens here. I mean, the truth of the matter is I'm grateful I have this, I'm grateful that it's working, and I'm grateful that I could read the code and learn like this, because this is fantastic. To be able to learn Python and PyCharm and virtual environments with Python and notebooks, and be able to run something that's going to work and actually produce Amazon resources that work and exhibit observability is just fantastic. Okay, so let's see what's happening here. I finished. So we're launching the cloud, the Agentcore. We can, memory is disabled, so we didn't set any memory. We have an agent running in my Amazon account in this West region. It registered something in the ECR repository for the agent. Repository doesn't exist. We are creating a new repository. If you get an error, you have to go remove your repository. Okay, what happened here? Role, account, role name it created. Role doesn't exist. Starting execution role, creating it, role created. Policy attached. We attached a policy. Roles ready, role name. Code build role doesn't exist. We're creating it. Creating an IAM role. Role created. Attaching an inline policy. Policy attached. Code build execution role complete. Using Docker ignore. Upload source to S3. Created a code build. Starting code build. Starting code build monitoring. Here we have the code build running. Code build completed successfully. Project saved. Agent created and updated. CloudWatch log resource policy already configured. Xtrace destination configured. X-ray indexing configured. Okay, transaction search was already fully configured because we had to set that in the previous demo. And let's see what else. We have logs and traces, observability enabled. polling for endpoint to be ready. It gives me the agent logs already. View recent logs, blah, blah, blah. So the check mark is here. We're finished with this cell. Okay, we launched, we threw everything on Amazon, my Amazon Web Services account. This is my credentials I have on my laptop. It took the credentials and automatically did it, which is fantastic. I don't mean to get excited about this, but you would, sometimes you do have problems with these demos, but sometimes they work. Okay, now let's look at this one. We're going to get an invoke response. We're invoking a prompt. Summarize the agent conversation for Jane Doe. Tell me exactly the phone number, name, and address, and email. Let's run it. So notice it showed me the email, showed me the name, showed me the phone number. Well, this is PII information. If it gave it back to the user, then it logged it that way. It's like, it could log it and mask it, because you could actually generate the PII data both ways in Amazon and use them for different purposes. But let's just now look at this. Okay, I'm going to create a guardrail, and this is interesting because I usually go and do these things manually. It's nice to see a code sample. So what it does is it uses the SDK, and it creates a guardrail using the Bedrock client. Now notice the Bedrock client was retrieved using Boto 3. So now I'm going to create a guardrail. Sensitive information prevents the model from revealing sensitive information, including PII and PHI. And notice, looks at the email, the phone, and I think this might be a keyword for that used to be called PII type. Well, it is still called PII type when you're using contact lens and something like that. Maybe this is a different phrase for it. So let's see what it does. Or maybe this is doing the mask here. I don't know, but that's not. Usually you can control the mask, but account number, if it matches this, okay, and then there's these messages. So create a response, and it gives you back the guardrail ID. So let's see, I created a guardrail. Okay, let's run this. And they wanted the guardrail ID back. And that's it right here. There's the ARN for the guardrail. Now let's see what this does. Create guardrail version. Version 1. Now this is called data protection. This is writing over the data protection PY. The data protection PY was Yeah, it was up here. We wrote data protection PY. Now we're writing over it. Let's do it again. It probably is the same code. It looks like the same code. Bedrock model is the same. It logs it's logging the guardrail here in the version. Now, guardrail trace is enabled. So that's something different here. Guardrail version, guardrail ID. So here with the model, we use guardrails. Let's go back up and see what the get bedrock model has for the other code. The bedrock model that has these things but does not have anything about the guardrails. So there's the difference. And basically what we could do is take a look at what's happening here. Same exact code, just printing out the guardrails. So we rewrote that. Still didn't appear here, which is kind of weird. Launch result. That must be showing the previous launch result. Now let's run this one. Once again, we're building and deploying, right? So we created a Docker file with an image. We're running the app entry point in Docker. So we need everything we need here, and it goes over to Amazon and creates the ECR registry, the code pipeline. And let's see what happens here. Okay, we got a check mark here, a green check mark, so we're finished. Let's now invoke this. Now this imports, we're looking at the log groups here. Log group name, response, put data protection policy on the log group. Okay, so it did the data protection on the phone number, the social security number, and everything else like that. Now we're invoking it again. And now it's hiding the information. Okay, so the guardrails did work. And now, now we're cleaning up over here, which is good. I like the cleanup code. But one thing we should do, let me see if I could do this. I don't know which account I'm in right now, but this is production. So what I'm going to do is sign out. Now I'm going to sign back in. I'm in what I call a development environment in my Amazon account, but it's really a kind of like a QA environment. But the thing is, it's not production. Okay, so let me see what I have here. I want this one, and I think Bob is the administrator. Although my name is Steve, I call him Bob because it's easier. Sometimes I get locked out accounts and I create a user account in the admin group so I could get back in. Okay, so now let's look at this. Amazon Bedrock Agentcore. Now what I'm going to do is take a look at my agents. No, it's not necessarily that intuitive what I should look at. So I'm going to go to my runtime. I'm going to take a look at my runtime. I have customer support agent. I think that's what I want. I click here, version 2, default ready, version 1, version 2. Tracing is enabled, notice. Okay, so let me look at version 2. Notice here's my Bedrock guardrails. Here's my observability. It's kind of interesting though, because like I said, it's not as intuitive as you like. It's not, then again, Amazon Connect and other, Amazon Connect's kind of intuitive, but it's getting to be a little bit more or less intuitive with integrations and other things. And by the way, the Agentcore integration with Amazon Connect is a doozy as well. Okay, so this one agent here, my customer support agent, version 2, I got 3 traces. I use this many tokens. Let's just take a look at it. So notice there's the average span and latency here in milliseconds. So the numbers are pretty large. I mean, it's 4 seconds, 4 seconds, 2 seconds. And notice there's different steps, right? Execute loop, invoke strands agent. Execute tool. And that was fast because it was just a dummy tool, right? It just gave us back a conversation. So here's the sessions and the traces. Here's the token usage. Didn't get any errors, but let's take a look. Okay, here's memory consumption and vCPU consumption. Not that interested right now, but what we want is we can go to traces. Let's go to sessions. So this is a session ID, and this is like okay, if you keep track of the customer talking to the agent, you could have a session, or you could just look at traces, and there's a lot of trace IDs. I would imagine there's 3, but the point is that if you look at the spans, right? So this trace was a request response from the customer, but there were 10 spans. So the input was, you're an expert specializing in whatever. Let's look at the trace. And there should be 10 spans here. So with the observability, what we do is we get 10 spans if you count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you see the conversation here. User message, assistant message. You see the tool. The tool was interrupted. I don't know why this happened. Now notice there's timings over here. So I'm looking at these large numbers, and they were kind of listed as spans, right? Because each one takes time, and we might want to look at each one from a time perspective. See, if we look at a timeline here, basically see the amount of time that each span took and how it contributed to the overall time. So there's a lot of seconds going on over here. Keep that in mind. And you could, and Claude, inside Claude, you're not too bad. You're like a 2-second window. But if you fine tune this LLM model and you did other optimization techniques, you can get this time down quickly. So you'd have to figure out how much this is affecting your overall conversations. Okay, and then there's a trajectory here, and I could zoom in on it. So Agentcore runtime invoke, invocations, and it has the timings here too. Milliseconds and times. Then there's an event loop, 2 seconds, 1 second, 3 seconds, and then down here we're calling Claude is 2 seconds, 2 seconds. So it gives you an idea of what has transpired in the conversation. And these numbers up here, agent spans 10, latency, and the number of tokens. Now, needless to say, folks, this is going to be really tough, because a lot of times you're fine-tuning an API, and here you're really fine-tuning a conversation, so it goes round trip, and there's a lot of stuff involved to give intelligent answers. So these timings are a problem, and if you're working on optimizing this, you will be trying to figure out how to make this make each one of these spans faster if necessary. So that's why the machine learning, the fine-tuning models, the optimization, the referencing the model quickly, using a smaller model to just use distillation or whatever, distill a model. There's plenty of things you can do. However, it's going to be a lot of work to get those numbers down. And then on top of that, you've got expenses happening here. So you could also speed up your code by not asking for too much information, requiring less output, etc. Okay, so that's all we wanted to show. I hope you enjoyed that. I'm sorry it was long and drawn out. So now what I'm going to do is I'm going to delete these things. Delete my guardrails. Delete my data protection policy. Delete my my ECR URL. What did I just do here? Oh, not good. Okay, I'm not going to worry about that, because I could go over here and do what I need to do later on. I'll make sure all of this stuff is removed. We didn't really look at sessions, but it's the same concept. You wind up looking at the trace IDs in the session. You have more than one trace ID in the session. Okay, so that's all you wanted to show, and thank you for joining.